Hi everybody, Clark Richey here, the Graph Guy. This week I'm actually been traveling and speaking at a conference in person for the first time in quite some time. So I can't really come to you live today, but we do have this video of the talk that I hope you'll find enjoying. So enjoy, and I'll see you soon. Take care.
So thank you, Steve. So relative to what you were saying about social media stars, I'm happy to introduce another social media star. So if you have the application Twitch, I'm about to introduce the Graph Guy, who has a Twitch channel and produces segments about Graph and Graph-related content, and it's really awesome. So please check that out. I'm sorry if you were going to say that, but please do that. So please welcome Clark Richey, the CTO of Beez.
Thanks again. Can you hear me okay? I don't think you need me to have this mic. Everyone hear me just fine? Can you hear me okay back there? Yeah, I'd rather hold this and click and move around a bit. Awesome. Awesome. Hey, okay. So I'm going to talk a bit about data orchestration, actually. Sorry for the confusion in some of the programs, whatever. But that's what I'm going to talk about. So just a little bit about me. Long story short, I've been doing this for a long time. Today I'm going to mostly talk a bit about data orchestration, how I view the concept. I'm going to talk a lot about what we do at Beez, give you a little bit of a demo, and tell you why I think this space is important. Unfortunately, especially for some of you in the back, it might be a little bit of an eye chart on some of the demos. I apologize for that in the videos, but I do have the application with me and on the table in the back, so we can do it up close and personal later if you are interested. Beez, right? We've worked with Neo for, like 9 years now, I want to say. For all the reasons that all the previous speakers have told you about, the goodness of graph and linked data. But what we're really interested in is building tools that aren't aimed at engineers, not at software engineers. So I've spent a lot of time writing software. I've spent a fair amount of time sort of in the sales space as well. So I used to work at a company called MarkLogic, which makes a database, and I ran public sector sales engineering for them. And one of the things I realized as I was in that space for a long time is we keep building better and better tools for doing data science, for doing data engineering, and they're super powerful, right? We've got really powerful databases like Neo4j. We've got tools like Hadoop and Apache Spark. But good God, are those complicated. Just setting one of those up, now Neo's not hard to set up, obviously, but try to set up like Apache, Hadoop, or Spark, you can invest some time. It's super hard for me to do it. I've got a master's degree in this. I don't have a PhD like most of the other people, but I do have a master's degree. I've been doing this for a long time. It's really, really hard for me. And yet we're asking now like our data scientists more and more to say, hey, please go find me value in all this data. Here's this truckload of tools that really don't have anything to do with finding value in the data directly. Go set them up and have fun. And then we wonder why our data scientists spend 80% of their time not doing data science. So I wanted us to write tools so that people could get to the job they're actually bringing value to the business. Things we're asking our data scientists to do, or analysts to do, are hard enough as it is. We don't need to make it harder. So when I think a bit about data orchestration, and again, I'm not a data scientist, but I think about it kind of in this process. I've worked with a lot of analysts in the government space and elsewhere, and I think it sort of goes like this, right? First of all, you have to come up with a model of your business, and we're going to talk extensively about this. It might be the whole business. It might be just a small portion of the business that you're interested in for your domain space, but you have to have some sort of conceptual model that matches what's happening. So you have to create that, and then you've got to load some sample data, right? You've got in your head already some sort of realm you're working in that you want to solve a problem for, right? So you need to get some data for that. And then you're going to test out some of your hypotheses. You think if you run certain type of analytics, certain type of queries, maybe chain them together, you're going to get some interesting results, or maybe not. So you may have to go back to the test and change your model. Maybe you didn't think about it right, or you need to bring in extra data. So you're going to kind of cycle through that probably a few times at least. And then once you finally hopefully get something out of that, you discover an algorithm or a set of queries that put together actually provide that business value. Well, now you have to operationalize it, right? You need to automate that as part of the business. And again, you don't want to spend most of your data scientist time doing that. You want them really in sort of that test model loading cycle, because that's where the really smart data scientist brains are working to provide value. But you still have to automate it, and then you have to deliver the results somewhere. Because if they just sit on a machine, who cares? So this is kind of the general workflow we're going to talk about today. I'm going to talk about each one of these elements and some of the aspects that I think are important in that, and give you sort of a little bit of demo, kind of just touching upon how we try to help making these things easier for people. So model, and I could say all day on this slide. I think this is maybe one of the most important parts. So earlier, I don't remember if it was Ken or we talked a bit about modeling and the whiteboard idea. I think this is the most crucial aspect. We talk about schema-free databases, and you always use a schema-free database, right? You don't have to have a schema. And that's cool. As a developer, I like that. It gives me flexibility, and I can change things really quickly. From a business point of view, if I put on my chief architect hat, and you tell me my enterprise doesn't have to have a schema, I'm going to throw you out, because that's crazy town. You have to know what is going to be in your database at all times. If people just throw in whatever they want, because the database doesn't make you have a schema, you're going to be living in crazyville. You're not going to get anything out of that database, because who knows what's in it and what it means. So you have to have a model. You've got to enforce the model. And most importantly, and I love this about Graph, the model that we can build is super expressive, and it's accessible by everyone. I've sat in the office of the CEO of Brands. Gentleman's older than we are, very, very smart, but he's not a technology guy. And we had a model of his entire business that was deployed in the tool. 52 circles with some lines between them. We printed it out really nice and we showed it to him. I didn't have to explain anything to him. He looked at it because they used his terms. It mapped his business. We built it by talking to the people who ran the business, and they explained to us how the business worked, by drawing circles and lines on a whiteboard, because that's how, as people, we tend to mostly reason about things. That became the model. He hung it on the wall. He understood it. And once you take away that disconnect between how engineering thinks about the data and how the business thinks about it, you've already solved probably 80% of your problems, in my mind. Most of the projects that I see go badly are because engineers walk into the room, the business explains how the data works, because it's always about the data. Then we go back and we translate that into what the machine wants, and those are not the same anymore. And then people start asking questions, and we translate it again back to how the model works, and the rift grows wider and wider. And you're in a deep, deep world of hurt at that point. But you don't have to be with Graph. So I love that. And of course, other important things you need to be able to do, right? You want to be able to version control your model. You want to be able to have it simple and easy to create and change. Simple and easy, if you haven't figured it out yet, is going to be the theme for this whole talk. And you want to enforce certain business rules, right? So that you know you have essentially clean data. You don't want to do analysis on junk data, essentially. So now we'll show you a little bit of a demo, and we'll talk through it about how you can create and enforce a model. So lots of ways to bring data in. You can do from scratch. You can bring a data dictionary. You can have a sample file. God help you if you have an ontology, but you can bring that in. You can load stuff you've already done. Here we'll go ahead and create one from scratch. So like I said, it's just like drawing on a whiteboard. Type in the names of the business entities that you care about. You see them appear over there on the right. Some of them get little pictures. Don't ask me why. So just keep doing that. Keep just typing the names of things you care about. Once you've done that, you can start to add properties to them as well. Again, just type in the property name under the thing you care about. You'll see that you get some data types there as well, so you can define what the structure should be. It should be a date versus a string. It should be currency value. So again, we can enforce some normalization. Make sure your data's in the right format. Once we've gone ahead and put all these properties in, Then we can go ahead and create the relationships as well. So you'll see that there's a bunch of the different data types. So we can change those. And we're going to create the relationships just by drawing the lines between the nodes. And that's fun and it's easy. And again, the great thing here is, I'm not even going to explain what the model does. I'm clearly doing a simple retail model because we all have some basic understanding of retail as consumers at least. But again, the superpower here is, and I've seen it time and time again, when you sit in a room with a customer, with a client, even internally, and you bring different parts of the business together, and you start drawing this out, you see organizations go, oh, I didn't know your organization used that data. Well, we do too, but we call it something else. And they never knew that before. Because no one ever sat everybody in the room together and drew a picture of how the business actually works. And that's what you're doing now. But the picture does become the data. So again, we can move things around. We're just going to draw some lines, give the relationships names, and no one needs to be taught how to think about this. Obviously, there is still some art to doing this at scale, but that's minute compared to what's going on here, right? This is the power. You also have the ability to enforce certain types of business rules. So, for example, if you've got a medical application, like you're doing billing, you probably have an internal rule that says customers can only have one billing address. Because, I got to send the bill somewhere. But it's a lot of times you get data coming in that has more than one billing address. Because, my billing address today is this, and in a week it's something else. Well, typically we ask our developers to do that. Here again, we're showing some validation as well on the values. So if you've got a SKU, it's got a certain type of a format, you can enforce all of that, again, right in here for your business rules. But in terms of the address, the system, you can automatically tell it basically, hey, if a new address comes in, detach your patient from the old address, attach the new one. Done. Do it in the model where the business rules belong. So here we're showing a bit about identities. Identities are super important. When data comes in, how do I know if it's a new customer or information about an existing customer? That's identity. It can be as simple as a single property, like customer ID. Or it can be more complicated, like multiple properties. It can even be a combination of properties and relationships to other things. And because the business so often needs is to bring data from different sources, where typically those different sources do not have a shared primary identity or a primary key, you can create a hierarchy of those. So here I said customer ID is the first identity. Second, if you don't have that, use the first name, the last name, and then lives that relationship to their address. Because that's probably good enough for what I'm going to go ahead and do when I'm perhaps joining my marketing data. So now your system can understand, excuse me, puberty's rough, can understand data from multiple different sources and bring it together, because logically we know it's the same data, even though our technology doesn't give us the same key. So that's a little bit about that here. This is doing what I did not want to do, which is looping. There we go. All right, so that's modeling in a nutshell, right? There's certainly more, but that's the core of it. Then you gotta get sample data. Well, unfortunately, it's just time again, whether you're trying to bring on a new client or you're working in a new area in your organization, particularly in sensitive areas of an organization. Even if you have the technology in your company and you're working there, it can be hard to get real sample data because there's internal controls over how to do that. Very often the systems that these things come from, particularly in large companies, are already overtaxed. So getting time to run your query against one of the data warehouses to pull out data for your sample project, good luck. Because that's running production queries all the time. So it can be really hard to get sample data. Generating it by hand, nightmare. I mean, who really wants to sit around and generate data by hand at any kind of scale useful for testing some sort of analysis? Nobody. It's terrible. And if you finally do get sample data, you might have to be running your tests on the production system, depending upon what your IT environment looks like. You got to make sure you don't interfere with any production data. So if I'm looking up sample customers, I don't want that to interfere with actual real customers in my database. So how do we deal with these challenges? Well, so this is a sample retail model that we sort of ship with to help people understand things. I'm just going to deploy this to the system for generating sample data so that we have something a little more interesting than very small model that I deployed a moment ago to show you how to build a model. So go ahead and deploy it to the system. Oh, it's supposed to be my water break. I missed it. So now, in this portion, this is where we're going to generate sample data. And again, we have our model. We're enforcing the model. We have to work with the model that the business decides. We're going to pick out a couple of those business entities that we want to create data for. And we're just going to say, I want to create data for this. So I'm going to give it a name. And you see there now all of the different properties that I defined in my model, along with their data type. ID has a star next to it. It's highlighted because I said that was the identity for this thing. So I've got to generate data for that. Otherwise, how would I know who this customer is? And then I can use a wide variety of, often silly but very useful, different types of data to generate based upon the values for these, based on the data types for this. So I can pick an SSN here for the ID. I can pick some other values as well. And down here in the bottom left, kind of middle left, I guess, I don't know. You can check, I can say how many rows of data do I want to generate. 1 row, 1,000 rows, 1,000,000 rows. Enough to make it useful, right? That's the idea. And so you can get nicely randomized values for all of these fields. So here I've got marital status. I think I choose gender as well. Maybe. Move the mouse around a bunch. You can scroll. There we go, gender. So then again, on your bottom left, you're starting to see the picture of what it is I'm actually building up for my sample data. Right? What am I actually doing there? So now that we've picked all of those, we can just go ahead and create the file. I'll give you one more. I'll leave you names. Sometime, come on, Back to the Future. Back to the Future, yes. So we're going to use, again, all kinds of things. Funny ones, silly ones, but a whole huge variety. So now we'll go ahead and we'll create the file. Timings are always harder when they're recorded. So again, we stick with 1,000 lines for right now. We're going to change it, make it 100. And that's going to generate that sample file. So that's going to sit in the file system. Ooh, I don't know if I can pause. If you wait till the video real quick, I promise so it's going to create the file. So now this basically simulates, I've got some data export a file of customer information. Great. But I care about orders as well. I know that for my analysis, I need customers, and I need orders, and I know they're going to come from different extracts because they live in different databases, they come in different files, for example. So now I'm also going to say I want orders. So we'll get the order. And of course, orders have an order identity and so on, and we can create that. But the most important thing is when I get the order in, it's also got customer information, right? That's how the IDs map. I know which customer made the order. So I'm going to pick a few things here to mock up for information about the order itself. And the critical things that got to be joined back to customers. And of course, what I want to do is I want to use values that I just generate from that other file, right? Because just saying make up random values here, who knows if they match the other file or not? That's not going to be great for my analysis. So after I finish the, I think, did we freeze? Oh, I hit a button. Oh dear. I hit a button. Can someone unhit the button for me? There we go. Okay, sorry. Good. Yeah, so after I finish filling this out, and don't hit any buttons while it's happening, we'll see what I'm going to do then is say, I also want to bring in that customer order information, and I'm going to bring it in from that file I generated a moment ago. So right now, we're going to go over, I'm going to do that. I'm going to click on the customer, and we're just going to add that customer information into this order mapping. So we're going to get a second, so there we go into the order mapping. And then we're going to get a second column here, which once again, is going to have all the options we have for our customer information. And now we say reference column. So this realizes already that I've created that other customer file. It knows the customer ID was mapped to that particular property. And so it becomes really easy for me to choose. And I choose what percentage of values do I want to pull from that other file. In this case, I want 100%. But again, maybe I want to simulate something a little different. I want 50% to come from that file, and the other 50% I want to generate new from here. I can do that too. It's up to you. But the important part is that, again, make it easy to create realistic data And that means you've got to be able to take information from that one file and bind it into this other file. So now I've done it. I've actually gone ahead, I've loaded the data, the load button, and we're going to get to the next in the moment. So, yes, question?
So is this generating synthetic data? Or
Yes.
Okay, so is it utilizing an algorithm plus graph, or?
It's the algorithm for generating the data is just using a free open source data generation tool that exists.
Okay.
So it's basically again looking at what's the data type of your property, and then you get to pick and say I want to use, this type of data to fill it.
Okay, and so this is for them to model it. If you utilize graph and do a graph model, what if you wanted to utilize that same sampling for machine learning models? Like, so you wanted to use graph plus your sample data and your graph model to create test algorithms.
Let me make sure I understand. Is your question, so here I'm showing generating data based on the graph model to load into the graph. We'll get to the loading part in a moment. And then, I think, is your question then,
So
what if I want to use data that's already in the graph?
Well, so like if I'm using, say, fake data, or generating fake data to make a map, to make a graph model, right, essentially, what am I going to do with that model once I create it and have sample data?
Right.
Like,
So this is going to load into the graph. We're
right,
going
but
to
we're putting it in the graph to do what with it then?
Right, we're going to get that's our testing portion that we're going to get. So step one, model. Step two, generate some data so we can get to, so we can load it, so we can then get to that testing. So let's do that next. So we generate the sample data, we hit the load button, so again it uses that map, that data model that we created, the sample data, to load that into our graph. So now the sample data that we've created, it's sitting in our graph and it's ready for us to start exploring. Testing's crucial, right? No one gets the query right in the first try, unless it's so trivial that, who cares? So you've got to test. It's too easy to make mistakes. And you want to test, lots of different algorithms. You want to test out the graph data science algorithms. You've got queries you want to run based on the results of that, and so on and so forth. And then, of course, once you do that, you've got to be able to quickly and easily transition to production. And again, wash, rinse, and repeat as the saying goes, right? Doesn't point right, adjust my model perhaps, maybe generate some new data, and try something different. So make it as simple as possible. So, testing, so again, I hit that the load button. Now I have this query button here. And say I want to go ahead and query against this sample data that I've created. Now, of course, if you're using Neo and you've got access directly to the database, you can just use Neo's tools to directly query the database, particularly if you're not in a production scenario, right? Go for it. We are not trying to duplicate the functionality of Bloom or their native browser here. What this is particularly useful in those situations, though, where you have to sort of share an environment, and so there may be existing data there. So here basically it gives you a simple way to write a query. We do some syntax highlighting for you, get some results. You can say, like, is this useful? Is this not actually useful? And I've mentioned a couple times, this is particularly useful for running production. Why is that? Well, when we loaded that sample data, for example, we did a little trick under the covers, and we essentially partitioned that off from your regular data. So that if I created, say, 10 customers here, and I only had 100 customers by database, no production query looking for customer will ever see my 10 sample customers. And when I run my test queries here, say again, counting customers, I will only ever be able to count my sample 10, not the ones in production, because we are slightly manipulating your queries to keep things segregated under the hood. So again, a very useful query tool if you're running in production and have to share. If not, and you have direct access to Neo, certainly you can use the load process here for creating and for creating the sample data and loading it. But you're more than welcome to go directly to Neo to use their more advanced direct access to query tools. Yes.
So your tool specifically is like modeling a graph before I even build a graph database or I want to connect to a graph database. I'm just modeling my data in graph and then generating some sample data so that I can essentially play with graph to prove it out for my business case.
And run your entire business. So we're taking care of all, so this is all hitting a Neo, an actual live running Neo database.
Right, but before you build.
Yeah, it can be at any stage along the way. So you might be completely at ground zero and you're trying to play and figure it out.
Right.
Or you might be
Conceptual model.
conceptual models.
Conceptual
Yeah.
model, or you could add above and beyond what you've already built to make a case for something else you want to build in your graph.
Absolutely.
Right?
Yep, or you can manage, to get an existing production graph. So
Right.
you see in the automation. So I've done this maybe in my development system to add on your case, but then in my actual production system, I'm using this as well to actually take the results of, oh, I've got a new operation I want to run, and I want to automate and deliver it, which we'll show here, so you can get those results going. Absolutely.
In the example you were showing, right, the top portion was your actual production graph database that you already have with production, and you were creating another model out of that, correct?
It could be a production database, or it could be a local test and dev, however you want to configure.
Could be, okay.
Yep.
So it's sort of you're constructing a model, designing a model, and supporting that model to database.
Yeah. Right. So that model that you saw drawn that's the shape of the data that's going to go into the Neo4j database. And as long as you continue to use the tool to load the data, it will enforce that model. Meaning, if you try to somehow create a relationship or a property that's not defined and deployed in that model, the system will not allow it.
So you can model your business in terms of semantics using the tool, and then it will create an instance for protection.
Yeah. So this talks directly to Neo4j, for instance. When you hit that deploy button you saw from that modeling screen, it's literally taking that model, it's writing it to the database, looking basically exactly like you saw it there. Because again, no disconnect between how we think about the data, how the data physically goes in, and then all your data will go in that shape. So we've created our model that we're going to enforce for our enterprise. We've created test data. We've run some queries based on that test data. We're happy with what we have. Now we're getting into actually productionizing things, right? We want to move this into production. So we've got to now actually map physical sources, right? So before I created sample data, it was a couple clicks, and it was great and it was easy. But in reality, I've got to get data from either typically flat files that live in my environment, or from existing databases that are in my environment as well. And I may have to do some basic transformations of those as well. So that's what we'll see here. So here I've got some files that already just sort of exist in my system, and they're pre-mapped. I've got some pre-done mappings that I've created, so you can see pictures of those. The ones that I actually created from my sample generation already exist. So if my actual data matches that exactly, I can go ahead and I can reuse those. I can go ahead and, in a production scenario, you might have lots and lots of these mappings. I can go ahead and find mappings that deal with specific business entities that I'm looking for very, very quickly here. So if I open up one of these, you can see this is a picture of a subset of that model we've created. Here I'm pulling in data that represents items and their color. So this is, of course, is a representation of the actual data itself. But in reality, let's go to a database. So here you can say, I created a connection to a data source in my environment, right? In this case, it's a MySQL. And it goes out and actually queries the database. It gets the entire set of tables for you. Lots and lots of tables. This is the Northwind database. And I want customers, so let me go and find customers. There's my customer table, so I can see what tables are there. I'm just going to pick what data I want to pull in from the database to populate into my graph model. So I've chosen a handful of them here. If I'm interested in what tables are related to that, I can go ahead and filter that down as well. But for the moment, I'm just going to go ahead and grab customers here to make a simple demo. So we pull a handful of rows from the database. That's live data from the database. Didn't have to write any SQL, so that's great. And now we're going to map that into the model we created. So there's an auto map button, which I just clicked, which compares the headers to what's in the mapping. It tries to make the best guess for you. The closer your things match, of course, the better that will be. And then I'm going to go ahead and validate the things that were mapped automatically to make sure they're correct. And then things that didn't map, I can just drag and drop them into where I need them to be. The numbers you see on top of the columns indicate how many times that column has been mapped. So that I drag postal code over, and I'll drag a street address over. So mapping, again, the physical data source into that graph model now. So now that I've done that, I'm going to go ahead and save that. This is my Northwind customers. And a really important part happens now, which is validation. It's a little bit of an eye chart. The system at this point essentially pretends to load that data and tells you what would have happened had it actually loaded it. This lets you ensure that what you just did there is what you actually meant to do. So if it's not, you can fix it at this point. And again, so we've got our saved mappings there we saw before. Oh, I think I've gone back again. We've looped. Yeah, so again, the validation absolutely critical. If I drag that wrong field of customer ID, I'm going to get weird results. That'll let me see that. Yes, sir.
This is really cool. So can you export or even import like something from RDF or how? Like if you have a model, can you
Right. So the question is, can you import or export from RDF? And the answer is yes. So if you actually have an OWL file in the first model page, you can click import from RDF. You can choose your OWL file, and it'll convert the OWL file into a model that looks like a normal property graph model.
The models only get created if we're working in property graph format in this tool?
Yes.
Convert to property graph?
This is direct. Yeah. This tool directly speaks to a. Well, primarily to Neo4j. Technically, any Bolt-enabled OpenCipher-powered property graph, you can count those on one hand. And there's really only one enterprise class one. So essentially, Neo. But yes. So we figured we want to do. We've now mapped our physical production sources, whether they be from flat files or from actual databases, into our production environment. Don't click that. And now we want to go ahead and automate that, right? So again, easy. It has to be easy. I found the thing I want to do. I want to be able to do it on a regular schedule. It has to be a powerful schedule. I got to be able to say, I want to run it every Sunday at 3 a.m. unless it's a holiday. I need to see the progress of my loads so I can understand what's happening, what's going to happen, and so on. Let's get off of, come on. They should never let me touch technology. Okay. All right, and so once you've automated that, of course, you got to deliver the results. The sad truth of that, of course, is not only to be in the right place, but a lot of our tools still don't natively speak to Graph. So yes, Neo has some connectors you can use, but this will also basically let you deliver those wherever you want to go. So do I want to email reports? Do I want to dump them to a file system? Do I want to FTP them? Do I want to stick them back into a relational database because half of my tools run on that? The answer is probably yes, right? Most of my IT workforce is probably still doing SQL. Is this the reality? So we got to give them results back to where they can expect it and leverage my existing IT investments. So let's see that. So here we're in sort of the pipeline section. That's an example of an active running pipeline. So think of a pipeline as an analytic task, right? This is going to get some data. It's going to go ahead and do some analysis on it and then deliver that result somewhere. So we're going to go ahead and create a new one. I'm going to go ahead and give it a name and a description. There we go. I talk faster than I type. Okay, so the first step is picking the data again. So I have these mappings. What data do I need to do to perform this analytic task? So I've picked one of those mappings. I'm choosing my database credential. So this one's getting it from a database. I can tell the system what to do with the data after it's actually been loaded. Do I want to keep it around and move it for later on, so if I need to do some sort of auditing, or do I want to get rid of it and save disk space? Get a nice little picture so I remember what I'm actually loading. And I can add other sources. Maybe I require more than one data source to run this analytic. I can choose more than one. Now I can add a whole set of other analyzers. So really, this is one that's already been created, and you can see it's got a set of analyses and a set of existing delivery options. So this is a really high level of reuse. So if someone's already built something that essentially is what I want to do, I can pick it, use it against my data source. I'm going to create my own though. So this is my B2B customer sample. And so again, analyzing jobs, existing smaller level analytic tasks, essentially queries, or utilizing the Graph Data Science library. I can reuse those because someone's already written it. Let's share that. See a variety of things you can do. My favorite, weekly connected clusters. So this is a great one. What we try to do, again, is make things simpler. So if you go through actually doing a lot of the Graph Data Science stuff, about 4 steps typically doing them. We try to basically condense them all into one step for you and automate that. So here you get a picture of your model again. So I know I never remember when I get to this point, did I call it customer? Was it B2B customer? Was it capitalized? You can see it all here. You can see all the properties. So in this case, I'm going to do just demo a simple Cypher query to pull some results. I'm going to put the Cypher in the job title. Why? Because I'm bad at things and I always do that. So I put it there. I'm going to move it down to what actually says Cypher in just a moment. But again, you can see I'm utilizing the key so I can remember what the actual property names are. Then I'm going to realize I put it in the wrong spot in a moment, and I'm going to put it in the right spot. There I go. I always do that. I don't know why. So I give it a name. So basically, I'm just going to run a query. So you can see it shows up there as a new analyzer job. Now, if I want, I can chain these things together. I can say I want to do this first and then something else. So, for example, I may first want to execute the weekly connected clustering or component for the Graph Data Science algorithm and then run something else against it. You saw when I click more than one, it shows you what order they're actually going to happen. So you can have multiple steps. Delivery, same thing. Here's pre-existing delivery tasks that some of my colleagues may have created. So if I want to just drop it off at an FTP location that someone's already set up, I can just click and reuse that. In this case, I'll create another one. I also can schedule the pipeline. So because I'm pulling from a database, I'm in control of when the data comes. It's not being pushed to me. So here I can say I want to run this, every so often days. I want to do it, start time, start date, end date. How often do I want to run it? In this case, I want to do it incrementally. So I'm from a database, from a customer table. So it's going to ask me what column from customers should I use to know essentially like when my last pull was. So we're going to choose. I think we choose typically use like customer ID or the transaction date. So if you run this every week, it'll pull all the transactions up to today's date. Remember that last date when it runs next time, and pull the next batch of transactions. So you get a nice incremental load. So there we've created a job. We make it active, and we can still go ahead and pull the data. Because we didn't schedule it, as soon as we turn it on, it's going to go ahead and activate it immediately. So it'll go out right away, it'll pull the data from the database and start to run our analytic process. And then it'll actually deactivate it itself, so it doesn't keep doing that because it's against a single run. So you see here when it ran, we get all the details of that. How many lines were pulled, what properties were pulled. The end of the properties fail the validation rules that we've created. Sometimes you expect something to do that because they're empty properties in some columns. But this is a great way to look at it too, to see like, oh wow, something weird is happening in my data perhaps. So you have the ability to see all of your results and the status of all of your existing running analytic pipelines. So essentially, again, to sum up, right? Neo delivers an unparalleled capability to do analytics on your graph. All the speakers before me talked about that, and they're totally right. But the reality is we pay our analysts, our data scientists, to deliver business insights, not to deliver the database, not to map physical sources into it, not to figure out how to schedule out on my jobs, to give me answers. And so we need tools so they can spend 90% of their time giving me answers, not dealing with this stuff. There's nothing really sexy about what I just showed you. I didn't deliver a single business answer. Unless the question you're asking is, how do I get more value out of my existing data scientists and analysts? And that's hopefully what we're here to help you do. And that's the end for me.
Okay, question.
Man.
So in the case of modeling and just relationships
Yeah, so Neo has some really great security features under role-based security. So that's always not. Let's go deep into like role-based security, which let's not break things, which requires all of the nuance and understanding of that within the organization. And, so that's certainly an option. But I think typically the entry it gets around understanding where does the data live, who has access to it, and what are the regulations. So a lot of times we have a very large financial customer, and yes, they have a lot of data so they hash it. So they essentially, it's not technically a hash because it's reversible. They essentially map it into something that, without the key, you can't get it back. So you can still see the patterns, but no one looking at that database could go, oh, that's Clark's social security number or Clark's address, whatever. So that type of mapping functionality is something we see a lot. And of course, it depends on your level of complexity and regulation, right? There are tools out there who just focus on,
Well, but giving graph creates new data points, i.e. the relationship between two data points. Like what kind of data are they classifying that as?
Yeah, so I'm not right. It depends on the industry and so. I think sort of the good news there is that they're not, because shockingly, government and financial regulators are not super up with current technology, so they're not. I think the good news right now, at least, is don't mention that to them, because they'll want to. That will undoubtedly want to start classifying relationships as PII. So let's not.
All right, Clark.
Thank you.
Thank you very much, Mark. That was awesome. The Zoom was really cool, isn't it? Right? That visual aspect of that tool, I love it.